What if I told you that humanity's next cosmic neighbor might be hiding a world that could change everything we think we know about planetary systems? Buckle up, because the discovery unfolding just 4.3 light-years from Earth is about to challenge some long-held assumptions about what's lurking in our galactic backyard. Researchers working with the University of Arizona's Steward Observatory have just delivered what could be the astronomical bombshell of our generation. Using NASA's cutting-edge James Webb Space Telescope, they've gathered compelling evidence that a massive planet, potentially comparable to Saturn in size, may be gracefully dancing around Alpha Centauri A, the brightest component of our Sun's nearest stellar family. But here's where it gets controversial. This isn't just any random cosmic discovery. We're potentially looking at a gas giant nestled comfortably within what scientists call the Goldilocks zone. That sweet spot around a star where conditions might be just right for liquid water to exist. Now, before you start packing your bags for an interstellar vacation, hold on. This planet itself likely can't support life as we understand it, being a gas giant rather than a rocky world like Earth. And this is the part most people miss. Even though the planet itself might be uninhabitable, it could host moons, potentially rocky Earth-like moons, that might harbor the conditions necessary for life to flourish. Think about it. We're talking about possible worlds supporting life literally next door to us in cosmic terms. Kevin Wagner, the assistant research professor at Steward Observatory, who's been spearheading this research, doesn't mince words about the significance. We are possibly looking at a planet in the habitable zone of the closest star, Wagner explains. Even though it's most likely a gas giant, we're still talking about a planet that could be orbited by moons in places where we could potentially envision life existing right next door. To help beginners understand the scale we're dealing with here, Alpha Centauri sits a mere 4.3 light-years away from our solar system. In astronomical terms, that's practically touching distance. If you could travel at the speed of light, which, unfortunately, physics says you can't, it would take you just over 4 years to reach this neighboring star system. The Alpha Centauri system itself is quite the stellar family reunion. Picture this. You have Alpha Centauri A and B, two sun-like stars, locked in a cosmic waltz around each other, plus a third, much smaller red dwarf star called Proxima Centauri, playing the distant cousin. Alpha Centauri A happens to be the third brightest star visible in Earth's night sky, though you'll need to be in the southern hemisphere to catch a glimpse of this celestial show. Here's where the detective work gets fascinating. The research team first caught a tantalizing hint of this planetary neighbor back in 2021. Wagner's earlier research suggested something intriguing might be lurking in the Alpha Centauri system, but they needed more concrete evidence. Enter the James Webb Space Telescope's mid-infrared instrument, MIRI, which has now provided what researchers are calling the strongest proof yet of this mysterious world. The technical challenges involved in spotting this planet are absolutely mind-boggling. Charles Beichmann from NASA's Jet Propulsion Laboratory, who co-authored the groundbreaking papers published in the astrophysical journal Letters, puts it in perspective. These are incredibly challenging observations to make, even with the world's most powerful space telescope, because these stars are so bright, close, and move across the sky quickly. Imagine trying to spot a firefly next to a blazing stadium floodlight from several miles away. And you'll start to appreciate the technical wizardry involved. The Webb telescope had to use a special coronagraphic mask to block out Alpha Centauri A's overwhelming brightness, revealing an object that's more than 10,000 times fainter than the star itself. But here's where things get really intriguing and potentially controversial among astronomers. When the team went back to look for their planetary candidate in February and April 2025, it had seemingly vanished. Now, some skeptics might jump to conclusions about measurement errors or wishful thinking. But Wagner and his colleagues have a compelling explanation that actually strengthens their case. Their computer simulations, which processed millions of potential orbital scenarios, suggest the planet follows a highly elliptical path around Alpha Centauri A. Think of it like a cosmic roller coaster that swings the planet anywhere from roughly the distance between Earth and our Sun, out to twice that distance. During those February and April observations, their models predict the planet would have been too close to its host star to be detected separately from the star's overwhelming glare. When all you have is a dot of light next to a star, you may or may not be looking at an actual planet, Wagner candidly admits. But when you see a dot of the same brightness several years later on the opposite side of the star, the story becomes much more compelling. The implications of this discovery extend far beyond just adding another entry to our catalog of exoplanets. If confirmed, this world would claim the title of being the closest exoplanet to Earth, that orbits within the habitable zone of a sun-like star. That proximity makes it an invaluable laboratory for understanding how planetary systems form and evolve, potentially offering insights that could reshape our understanding of our own cosmic neighborhood. The research team isn't resting on their laurels, though. They've calculated that the optimal viewing window for their next confirmation attempt will arrive in fall 2026. Wagner expresses the anticipation felt by the entire astronomical community. The observations and orbital simulations provide us with a prediction for where the planet will be in the future, and the best time for us to go back and look at it will be in fall of next year. We look forward to that opportunity to confirm its identity beyond any doubt. But here's the question that's dividing the scientific community. Are we getting ahead of ourselves with this discovery? Some researchers argue that extraordinary claims require extraordinary evidence, and that we should temper our excitement until we have ironclad confirmation. Others contend that the accumulating evidence, combined with sophisticated orbital modeling, already paints a compelling picture that deserves serious consideration. What do you think? Are we witnessing the discovery of a planetary system that could fundamentally change our perspective on life in the universe? Or should we maintain healthy skepticism until that crucial 2026 observation confirms what we hope we're seeing? The stakes couldn't be higher. We might be looking at humanity's first realistic target for interstellar exploration, complete with potentially habitable moons that could harbor life just a cosmic stone's throw from home. The debate is just beginning, and your perspective matters. What side of this astronomical controversy do you find yourself on?